Module 7 was all about solving quadratic equations. We had a when to do what worksheet, and there's a video that goes along with that. You could review that to get more detail. To solve by factoring, we need to have our equation set equal to 0. So you're always going to need it to be ax squared plus bx plus c equals 0 before you can factor. You don't always have all of the terms, but it has to be equal to 0. I'm going to focus in on c. And for any solving, you want to first look for a greatest common factor. And I do have a common factor that can divide out, which is 5. And that leaves me with x squared minus x minus 2 equals 0. And then I'm looking for factors of a times c. That's the first and the last term. So that's -2. And there's really only one set of factors, 1 and 2. And because it needs to be negative, I know that one of my terms needs to be negative. And because my middle term is negative, I know I want the bigger one to be negative. And that does 1 plus -2 or 1 minus 2 does equal -1. So that is our factor. So we can use the box method again. X squared minus x minus 2. And we've already figured out what goes in here is our 1x and our minus 2x. Now, of course, I could have exchanged these. These could have been reversed. You're going to get the same answers. And now I'm going to look across the top row. An x can divide out. In my bottom row, a -2. Remember, if this is negative on the outside edge, then my factor is negative. In my left column, an x can divide out. And in my right column, the greatest common factor is 1. So I'm just going to put a 1 there as a placeholder. So now I can rewrite standard form in factored form, and I have x minus 2 and x plus 1 equal to 0. A product of two things multiply to 0. I know that one or both of those things must be equal to 0. We call that the zero product property, and that's what we're using to solve this. If x minus 2 times x plus 1 equals 0, then either x minus 2 has to equal 0 or x plus 1 has to equal 0 or both. And these are just two little mini equations. If I am subtracting 2, I'm going to add 2 to both sides to cancel that out here. So I end up with x is equal to 2. Subtract 1 from both sides from the other mini equation, and I'm left with x equals -1. So I have two answers. And remember that quadratics, whenever you have a power of 2, you're looking for two answers. You don't always have two answers, but most of the time you do, and you want to make sure that you're looking out for that. Looking at part D, again, we're looking for greatest common factor first, and I can see that I have an x here and an x here, so I'm able to divide an x out of both of these, and so I write that factor on the outside. X squared divided by x leaves me just x, and I still have my subtraction. And then 2x divided by x, the x's would cancel, leaving me just that subtract 2. And so by factoring out the greatest common factor in this scenario, I have already factored my whole polynomial. I don't have anything left to do other than set my factors equal to 0. Because if this product equals 0, then x has to equal 0 or x minus 2 has to equal 0. So I have one of my answers of x equals 0. My other is to add 2 to both sides. So x equals 0 and x equals 2 are my answers. Another way we can solve quadratic equations is by using the quadratic formula. And just like factoring, we do need our equation to be ax squared plus bx plus c equals 0. We have to have it set equal to 0 in order to solve it. So if we have our equation set equal to 0, you can use the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And one of the benefits of using this kind of complex formula is that it works 100% of the time. Looking at part A here, I have 2x squared minus 2 equals 5x. I'm not equal to 0. To make my equation equal to 0, I am going to subtract 5x from both sides. So 5x minus 5x is 0. And I don't have any like terms on the left. I'm going to rewrite these terms in standard form. So I have 2x squared minus 5x minus 2. And then when I'm doing the quadratic formula, I'm going to write down my a, b, and c. So my a value is 2. My b value is negative 5 because we keep that sign with our number. And my c value is negative 2. So I would have x equals the opposite of b. So if I have negative 5, it's going to be positive 5 right here, plus or minus the square root of b squared. So that's going to be negative 5 squared minus 4, part of my equation, times the a value, which is 2, times my c value, which is negative 2. And this whole thing is divided by 2 times a, which is 2. So when I'm working on this, I simplify what's under the radical before I evaluate anything. And 2 times 2 is 4 on the bottom. So I'm going to have 5 plus or minus whatever this whole thing simplifies to divided by 4. So you would put this whole thing in your calculator. And when you do that using parentheses, you should get 41, the square root of 41. And 41 is a prime number, so that means we're actually done simplifying. Now remember when we graph this, we got the decimal, but when we're just solving, oftentimes they ask us to leave it in the exact value, which would be leaving the square root simplified if possible, but as a square root. Square root method, I said we'd talk about the square root method. There cannot have an x term. So it cannot have just x. So when I scan through here, say I have an x squared and a constant, an x squared and constants, an x squared and constants, no just x term. And then we try to get x squared by itself. So get x squared equals something, and then we're going to have plus or minus the square root. That's how we're going to solve this. Taking a look at b, we're trying to get x squared by itself, which means I'm trying to get rid of this negative 5 right here. So to get rid of a subtract 5, I would add 5 to both sides of my equation. And so I'm left with x squared on the left because that canceled out. Negative 5 plus 5 is negative 5. My next step here would be to square root both sides. And I would add my plus or minus here. But if I have a negative under my radical, you can try that on your calculator. You're usually going to get something called a domain error or just an error. And it's because we cannot square root a negative value. And what we would say our answer is no real solution. And finally, let's simplify some radicals here. We didn't have to simplify on the example I did above, so we'll practice here. Let's take a look at this 300. I see right away that this would be 3 times 100, even though 2 does divide in there. 100 is a nice number because I know that that is 10 times 10. And so I don't have to break it up into primes if I find a perfect square. So I see that I have 10 times 10, that's my pair. So the pair goes under one radical. Anything else goes in a different radical. So I only had 3 hanging out here the way I did this. There are other ways to simplify this. And the square root of 10 times 10 is the square root of 100, which is just 10. And I have that square root of 3 there. So that would be my simplified answer. And you would do the same process looking for pairs for the square root of 45 also.